The lab write-up provides a diagram of a simple circuit. In an ordinary circuit, R could represent the equivalent resistance of an entire collection of resistors. In this case, R is a variable resistor, represented by the resistor symbol with an arrow through it. When it comes to this lab, we will change this value to gather data. The EMF V represents an ideal voltage source, rated at a certain voltage. But because of energy conservation issues, as soon as you attach a voltage source to a circuit, you don't have the full voltage or EMF of the battery available to use with that circuit. A 3-volt battery, for example, provides you with 2.95 volts or 2.97 volts. It doesn't give you the full 3 volts. Now, you and I can't tell the difference initially, but as the battery gets older, we do notice. And that's when we end up changing the battery. What we're going to explore is the observations that batteries have a finite lifetime. The relationship between the EMF, the voltage, and the current going through the resistance is given by the expression terminal velocity V is equal to EMF epsilon minus the product of current I times R. Here, small r is called the internal resistance, and the product IR represents the energy losses internal to the battery once it is connected to the circuit. So R is not a physical resistor inside the voltage source. Once the circuit is constructed, you are to collect resistance, voltage, and current values. Changing the value of the resistor allows the measurement of voltage and current. You'll be plotting these latter two to make a graph. Plot voltage on the vertical axis and current on the horizontal axis. If you use Excel, make sure the columns are placed properly to get the appropriate graph. The line fit to your data set should be projected to both the y-axis and the x-axis. The equation used to fit the line, Excel can give you this equation, should appear on the graph. It contains the internal resistance and the initial EMF of the power supply. Use the relationship between terminal voltage, EMF, and the product of current and internal resistance to make these identifications. What you will submit. Your lab write-up should include a complete data table and answers to the questions asked. There should be a graph with proper axes labels and proper title, fitted line, equation for the fitted line, and the fitted line should project to both the x and y intercepts. There are % error calculations that should be completed on a separate calculations page.